Chapter 22, nutrition. Some of you have done a little bit of this, some of you have not. To me, the last several chapters of that we do are just sort of, okay, you know. Yeah, so there are some big things in it that you do need to understand, but for the most part, it's like, okay, we've learned the hard stuff. This is not hard stuff. So first thing we're going to do is we're going to go into a case study, and I'm going to have you read and see what you think about what's going on here. There has been a real big push for breastfeeding. No. Okay, I like the discussion that's going on. So we talked about, this thing talked about best thing nutritionally for preemies. They've really been pushing breast milk because breast milk actually changes with the age of the baby. You first have colostrum and then it goes into heavier fats that the baby needs to develop. How often did they say that she should pump? It's a lot of but if you think about it, a new baby eats every 2 to 3 hours. So that's important. How long till the baby could nurse? How long did they say that? 5 weeks. When a baby is premature, they actually can't suck. I've had 3 premature babies, and they can't suck. They have to learn to suck. So they have to learn to suck, and it takes a lot of energy. Okay, we found out what JDRF was, which was what? Research Foundation. Okay, why would they be interested in breastfeeding? Okay.
If your baby got diabetes and you give sweets, then it's going to get sweets too much and it will have a problem.
Well, actually, they have found that breastfed babies don't tend to get diabetes as often as non-breastfed babies.
See, how are we supposed to know that?
Added sugars in formula.
Right, because they actually do have added sugars in formulas. They've actually broken down a lot of the formulas have the sugars broken down to the simplest form, where breast milk is not to the simplest form. Babies have to digest it, have to get their systems going. Yes, it smartens their systems. Okay, so we've got nutritional requirements, and a lot of this has been in other classes that I've heard you guys tell that you have taken. We've got macronutrients versus micronutrients. Macronutrients that are what our body needs in large amounts, and micronutrients are those that they need in small amounts. So macronutrients include carbohydrates, fats, protein, water. We need a lot of water. Micronutrients are vitamins, minerals, and fiber. So just by saying macro and micro, you should be able to get which one you need more of. And think about which ones you do need a lot of versus what ones you don't need so much of. Okay? Okay, so we've got a lot of definitions that we need to be familiar with. Good. So RDI is reference daily intake. It's a set of standards for protein, vitamins, and minerals used on food labels as part of the daily values. DRV is daily reference values, and it's a set of standards for nutrients and food components such as fat and fiber that have important relationships with health used in food labels as part of our daily values. And DVs are our daily values. The reference developed by the FDA specifically for use on food labels. They represent 2 standards, the RDI and the DRV. So on the far side over here, I thought this was sort of interesting. I found on the internet here. Average refined grain intake, and you look at the bottom, it's actually the years. So as we get to about 14 to 30, we've got a very high, compared to the rest of them, intake of grains. The range of recommended grains is a lot lower than what we intake. Any reason why you think we would take more intake of grains than we should? It's refined grains. So it's stuff like chips and pizza and white breads and stuff like that. The green down here is the average amount of whole grains, so whole wheat and whole grain cereals and whole grain stuff that are supposed to be good for you. And you see we've got a large variance of what we should compared to what we need to be eating. This green one up here at the top sort of tells us what we need to, in general, be eating to keep our body moving and keeping it going. Sodium helps us with our electrolytes. Sugars, we need to have some kind of sugars to keep going. But it sort of gives you a general idea there. So we've got nutrient labels, and we've gone from old nutrient labels to new nutrient labels. And there's been some things that have been cut out. Okay, they have cut out trans fat. Trans fat is no longer there. It used to be shown, and it's no longer there. Added sugars. They just say sugars now, not added. So total sugars. They don't really tell you how much of the diet there is. It's already included up here, so they don't say that overall it's this much. Instead of just listing the ingredients now, the new labels say these are the major ingredients and these are the ones that are less than 2% of all the ingredients. So it sort of separates it out. So this just happened in the last few years. So your book is out of date as far as that goes. So now you have a more up-to-date version than that. Okay, and they have, if you look at it compared to over here, enriched bleach flour, wheat flour, and over here refined bleach flour, wheat flour, niacin, iron, thiamine. Some of the enriched flours have other things added to them, so they've now had to include those. Okay. So choosemyplate.gov is one of the places that you can go to look at different things. You'll notice that the current, actually the old version, had the calories small. And they always had sizes of servings that were very small. If you got a thing of chips, one of those packaged chips, it said it was 2 servings. Well, I don't see anybody that's going to eat that in 2 servings. Everybody just eats it in 1. So now what they're doing is getting it more realistic as far as, as far as the serving size, it needs to be what I'm actually eating. Now, this one doesn't show that, but that's one of the things that they have upgraded on the other. And it does tell me how many servings in large number or large letters that this thing is supposed to be. So if you get a candy bar, notice how many servings that candy bar is really supposed to be. And that sort of makes me laugh. Yep. Yep. So that didn't go where I wanted it to go, but that's okay. All right, so macronutrients, we're going to talk about those for a minute. We've got simple carbohydrates and complex carbohydrates. So if you wanted to go more into and see more what's going on at myplate.gov, we'll give you a whole bunch more stuff there. Simple carbohydrates are your monosaccharides, amylose, amylopectane, and these are we call them sugars. So simple carbohydrates are our sugars. Complex carbohydrates are the polysaccharides, the amylose, and the amylopectine, which are called starches. I think I screwed up there because, no, polysaccharides. So they're many saccharides long. And we do call them starches. And they tend to, when we talk about starches, they tend to be long chains that are repeating. Okay, sort of like the pleated that we talked about earlier. So I like this. What kind of person are you growing up to be? Are you growing up to be a hamburger, eggs, and soda and that? Are you growing up to be a fruit and vegetable kind of person? And, whoops, sorry, I just went forward and I didn't want it to. This one, what sounds better, an apple or a hamburger and fries? It's all about what we learn how to eat. And so for $20, you could go to KFC and you could buy this. Or you could buy all of this, which would feed a lot more. Okay?
Both those
Well, good for you.
This one, the one like
on the right?
Yeah, it looks anorexic.
Oh, it looks anorexic.
Like look at it.
Is
No
that how
hips.
it looks in the book? Or
Yeah, like
it doesn't
you,
look
like
bigger
you,
in the
you
book?
need
I don't know if this one's in the book or not.
hips are there so that you can have a baby.
Oh.
So it's like, if you
Okay.
don't have that and hips,
What's
You were
I don't know.
class
And then there's like, I don't know, there's no fat on the body.
Okay, so
95.
looking at a normal intake at or above recommended or below limit. So as we're looking at eating things like vegetables, fruit, grains, dairy, protein foods, oils, added sugar, saturated fats, and sodium, we need to be careful on what we're choosing, because added sugar, saturated fats, and sodium, we just need a minor amount of. We don't need a large amount of. And so we need to make sure our normal scale of eating is backwards from what it should be. Okay, so we've got a lot of different oils that we can talk about. And there's been a lot of people that have been talking about, oh, the benefits of coconut oil. You've got to have coconut oil.
Coconut oil's so bad for you, actually. It raises your LDLs, and it doesn't give you any for HDLs.
Yes.
Yeah.
So you have to be really careful. Coconut oil makes great soap, though.
Yeah.
So depending on what you use it for,
I've been using it.
is it
It
good?
says it's healthy, but then I learned freaking
So yeah, so sunflower oils, we've got long chains, and we've got linoleic and oleic acid. Olive oil is basically oleic acid, which is a long chain. A medium chain is like a red coconut oil, and it's only 47 to 53 lauric acid. And a medium chain would be a virgin coconut oil, which is 47 to 53 lauric acid. So it's got different acids in it. And they put the little heart here because they're supposed to be heart healthy. But you've got to be really careful. The coconut oil has found to have some saturated stuff in it. This is mostly unsaturated olive oil. And so you have to be, olive oil is very good for you. And you can sort of go see the different things. Palm oil, we use that. Somebody used it for their soap, that red palm oil. Okay. All right, so soil, to look at a better comparison, this one is more like what's in your book. On page 721. This one gives you a breakdown. You want one that has high monosaturated, one that is not saturated, heavy and saturated. If you look at here, coconut oil is 92% saturated fat. Your body has a hard time breaking down saturated fat, okay, because there's no place to get in and break that into smaller chains. Palm kernel is also. As we get into soybean, a lot of the Asians use peanut oil. Okay, canola oil is behind here, where you can see the thing going back and forth.
So you want it to be either yellow or blue, not red.
Right. So, well, polyunsaturated just means I have many unsaturated bonds. So it's got a lot of places I can break it up.
Yeah, because
Right.
I
So
think
you want to at least, monounsaturated means I have one place it can break up, but polyunsaturated means I have many places I can break it up. But polyunsaturated does not, it's like, it's got lots of bends in it. And if you remember our triglycerides that have 3 fatty acids, try and get 3 fatty acids that have lots of bends in them is hard. But if it has one bend, it's probably okay. We can probably work around that one bend. So for our body, monosaturated is easiest to work with. Polyunsaturated puts us to more work, our body to work. Yeah, works harder. Okay, let's go on. So we've got protein. And protein is made up of amino acids, and we've learned this. And in the amino acids, we've got the essential and non-essential. Essential are things that we have to obtain from nutrition. There's no other way we can get them. The non-essential, our body can make. And they're listed up there. To have a complete protein in food that contains all the amino acids in the proportions needed by the body, that's hard to come by. A complementary source over here, deficient in lysine, high in methionine and cysteine, grains, nuts, oils, cornmeal, oats, rice, basically things that our ancestors used to eat a lot of because that's all they had. Okay? Legumes which are beans and chickpeas, lentils, peanuts, soybeans. These are deficient in methanol and cytosine, but high in lysine. So if we had a combination of these two, which is basically what, like I said, our ancestors had, which was this combination of beans and lentils and barley and buckwheat and oats and seeds, then we have a complete protein source. Okay? We good to move? Okay, so fat-soluble vitamins. These are things that can only be dissolved in oil or fats. And we need to make sure that we eat them with oils or fats, because if we don't, they just pass right through our body. They don't get dissolved. It's vitamin A. The source we can get it in is fish liver oils, green vegetables, green and yellow fruits. If you go to Italy or places like that, they usually use an olive oil or an oil and vinaigrette dressing. And that's because, well, I don't know if that's because, but because of that, their body can absorb more of the nutrients that are fat soluble, because the oil is with your vegetable. So it breaks it down easier for you. Functions for vitamin A, most of you should have known, everybody says, oh, it's a carrot. Vitamin A, it's for your eyes. But it's also for immunity. Deficiency, if I don't have enough vitamin A, your growth is retarded, you get hyperketosis, and don't ask me what xerothamilia is, however you say that. If I have too much, and I actually had a cousin that all she ate was carrots. She didn't eat anything else, and she actually went toxic on that. There's nausea, vomiting, anorexia, palmyredia, whatever, and tia, whatever. But basically, her skin basically went orange, and she started getting like the belly of the kids that are starving to death, and it was pretty gross until she finally changed her diet because she was on this fad. Okay, vitamin D, the sources of sunlight, foods of animal origin, so proteins with animal. Functions with our calcium and phosphorus metabolism and bones. Deficiency gives us rickets, or bones break. They don't have a toxicity level on that one. But if you eat too much vitamin D, you can actually calcify parts of your kidneys, and you can get kidney stones. Vitamin E, vegetable oils, egg yolk, cytotoxic effects of the lipnocytes, which means basically you've got some bad things going on. On this one, green vegetables, vitamin K. A lot of us, my parents always said, well, eat more bananas, you'll need more vitamin K. But you have to be careful with vitamin K, because vitamin K has to do with your heart health too. And if you eat too much vitamin K, you have problems with your heart. And it's not listed here, but that is one of the problems. It's used for blood clotting. So people that have problems with blood clotting usually are low in vitamin K. People that have heart problems are high in vitamin K. So, all right, so vitamin B1. This is where you have cereals that are from rice. It's used to metabolize your carbohydrates. A deficiency there's cardiac problems, infantile, cardiac, and encephalocystis, which is your neck. Vitamin B2 you get from liver, eggs, and pulses, and again, cellular oxidation and integrity. I don't know what angular stomatitis is, sorry. And then vitamin B3, we've got animal products. It's to help maintain skin and nervous system and intestinal function. Diarrhea, dermatitis, which is skin rashes, and dementia, if you don't get enough of that. Vitamin B6 you get from cereals and vegetables, and this is where we get our amino acid, fats, and carbohydrate metabolism. And peripheral neuritis is, peripheral means on the side, neuritis is with the nerves. Okay, so then we're going to go to chemistry all around us, 2210, the 10 most dangerous foods to eat while driving.
Why would you give us on and eating?
I love these pictures. So go to 724 and let's read about this and then we'll talk about it, what you think, if they really are
I watch Criminal.
criminal minds, huh? Okay, so let's start talking about some of these. What are some of them, out of all of them, that you think are some of the worst? Those top 10.
Yeah.
Barbecued foods,
Did you hear about
coffee.
that girl where she like scalded her entire mouth because of McDonald's coffee? Yeah, she didn't even want to sue them. She just wanted compensation, but they wouldn't give her anything. Oh, they were in violation of like
It was too hot.
it was way too hot. It was like over 100 degrees more than it was supposed to be.
Well, did she drop it though? Is there like a hole in the cup?
Yeah, it burned through the cup.
Hmm.
Yeah.
That's miserable. Okay, so barbecue foods and hot coffee. Okay, what other things did you notice that might be?
Yeah, I spilled soup on my lap before and a tupper on it, and it burned. So I wasn't drinking, I was eating it. It was in my lap, and I hit a bump, and then it just flipped over on me, and then I burned.
So probably not a good thing to eat.
Ice cream cones.
Ice cream cones can be, or shakes.
I know this one time when I was walking out to the car, I hadn't even gotten to the car yet, and I had a plate full of pasta, and I slipped on ice and
Jeez.
You ever tried to eat a casserole while you're driving?
Casserole, great. Okay, so let's go on to this one right now. The vitamin water. And see what you think about this. This is pretty interesting to me, at least, because vitamin water was one of the things they had me start drinking when I was diabetic, but then I found out it was high in carbs.
I felt like the entire time I'm like vitamin water, that's just water.
Let's talk about this really quickly. What did you learn?
it's pointless.
It's pointless. Well, if it's right off the line, you're probably going to get vitamins. But what happens? Light and heat degrade it. So if you take it on a four-wheeling trip with you, all you're basically taking is flavored water, right? Okay. Okay, so let's look at some micronutrients. We got two different kinds of micronutrients. We're going to talk about micronutrients too. So minerals are metal or non-metal in the body in the form of ions of a compound required for growth, repair, regulation, and for vital body functions. There's two major groups. Again, we've got major minerals and minor minerals. Major minerals are ones we need in bigger than 5 grams quantities. And minor minerals are things we need in less than 5 gram quantities. Alan! I think you heard me. I got my computer. You want to fix it, please? Bringing.
Come down here earlier and
Thank you. I just saw you and I thought, I'm going to tell him. Thank you. All right, so going forward. Some major minerals that we got are calcium, phosphorus, sodium, potassium, magnesium, chlorine, and sulfur. These things we need in bigger than 5 gram quantities. Things that we need in trace amounts are iron, iodine, fluorine, zinc, copper, cobalt, arsenic, believe it or not, chromium, manganese, molybdenum, and nickel. I love saying molybdenum. It makes me happy. Sorry, it just does.
So what do we eat that has trace amounts of arsenic?
Your water. Okay. Other trace minerals that we need that are sometimes overlooked that people don't think about. Iodine is needed for thyroid. Iron is needed for your hemoglobin. That one a lot of people know about. Zinc we actually need for immune function. Chromium is needed for blood glucose balance and healthy cholesterol metabolism. And manganese is needed for healthy cell growth. And boron is needed to help keep joints healthy. And I think see if I can move this up. I can't can't remember what the molybdenum and that were. They were down farther. Sorry. But I can go out of this and then bring it up. Oh, it just said boron is needed to help keep healthy joints and to prevent arthritis, so that really didn't help me. Okay. Five inches by 7 inches, child.
Well, you could have told me that before I started.
I didn't know what you were doing. Okay, so essential minerals. It's in your on your book on page 727. So as I'm talking about these, you can look at it there. Iron, we get, I know my grandmother used to always say, you need to eat your liver so you can have your iron, and all of us would just absolutely have a cow because none of us like liver. Yuck. You know, so poultry, fish, cereal. Now they don't put iron as an ion in cereal. They actually put iron filings in cereal because your body needs to convert it to the iron, the Fe+2 in your body because it degrades so fast, and that's what your body uses. Leafy greens and jaggery. What?
Put like cereal in the blender, you can actually get the iron back.
Oh, you don't even have to put it in a blender. You can just put it with some water and put it on one of the stirring hot plates and just use the stir in there, and it'll stir and it'll collect all the magnets. Oh yeah, oh yeah. And we can, and that's one of our next coming up labs. Oh,
Sweet.
okay. We're going to blend cereal. Okay. Most of you know that iron has to do with anemia. Calcium, bones and teeth. That's, you've heard that forever. Phosphorus, though, bones and teeth also. Fluorine for bones and dental enamel. And iodine is for your thyroid hormone synthesis. Cod liver oil, they used to give them a lot on large, long sea trips. Yuck. If you've ever had cod liver oil, it's not something that you want to ever repeat. Whoa, let's go back here. Okay, so the flow of energy in the biosphere. So we do some nuclear reactions. If you remember nuclear reactions, hydrogen to hydrogen makes a deuterium. A deuterium and a hydrogen will make a tritium. And you'll notice that you got a beta particle coming off the first one and a gamma particle off the second. And then once I get to, well, this one is a helium, not a tritium. Once I get to the 3,2, then I can put two of those together and I can get a regular helium and get some more hydrogens off. So this is known as nuclear fusion, and we get energy off of it. Cellular respiration, the entire process involved in the use of oxygen by cells. Hi. Who? No. No, there's not a chance. Okay, so as we're breathing, and you probably heard this back in biology, okay? We take in oxygen, we breathe out carbon dioxide. And we do that through cellular respiration, where we've got glucose plus 6 oxygens will give us back and forth. It's actually an equilibrium arrow. 6 CO2s, 6 waters, and 36 ATP, which is energy that we can use for energy. And we get that through mitochondria. So we're able to eat and get energy off. And I thought this was probably the simplest, most simplistic way to look at it. This is what we need to be able to do. Okay, so cellular respiration, what happens, we get about 38 ATP, and we go through glycolysis from glucose to 2-pyruvate, and then you've got your 2 acetyl-CoAs, and you get into the Krebs cycle. You've got your 2 NADHs, here and here, 6 NADHs, 2 FADHs, and then you go into the electron transport chain. So we've done this from other things, and we're just now figuring out how much each time we get. So this first one, we only get 2 ATPs. The second, we get 2 ATPs. But when we go through the electron transport chain, we end up with another 34 ATPs. So energy flow in the biosphere, what we need to know. We take 4 hydrogens, nuclear fusion, and we get helium and energy. That energy is transferred into the grass, and we get photosynthesis happening, and we are able to make carbohydrates and oxygen. An animal eats those carbohydrates, breathes the oxygen, through respiration is making CO2 and water and energy. That's given off in heat and ATP. The ATP breaks down into chemical work, biosynthesis, mechanical work, muscle contractions, and osmotic work, active transport within the body. That's good. I told you these last few chapters, to me, it's like, oh, we've had this in biology, or we had this in nutrition, or we had this in health, and we've had this already. Mm-hmm.
Today we did the oximeter.
Oximeter.
How are you supposed to be like 90 to 100?
Uh-huh. They still consider it 90 and above okay. Once you drop below 90, then you're in anaerobic. Okay, we got these down almost. I'm writing super fast. I'm going to get it. I'm going to get it. It's going to go. Can't breathe. My allergies are going crazy. So, simplified carbon cycle. Photosynthesis, carbohydrates and oxygen, respiration, CO2 and water going to photosynthesis again. This is our simplified carbon cycle. Okay? Basic. That sounds like I need more oxygen. I actually have a meter on my phone that I can find out my oxygen levels. Okay, so let's talk about these. Metabolism and the overview of the energy production. So, metabolism is the sum of all reactions occurring in an organism. Catabolism is all reactions involved in the breakdown of biomolecules. Anabolism is all reactions involved in the synthesis of biomass.
Man, I wish I knew that for my test today.
I'm sorry.
Well, because we just said it was build up. She didn't say anything about this. Now I know what I got wrong.
Oh. Okay, metabolic pathway is a sequence of reactions used to produce one product or accomplish one process. So there is a lot of vocabulary, and if you're not familiar with the vocabulary, I would probably make myself, flip cards.
Are we going to need to know, like, each one of the vitamins and what they do and the deficiencies and stuff like that? Please?
Yeah. There are a lot. But a lot of them we already knew. I mean, calcium, you know what that is. There's a lot that we already know, so it's just those few that you don't know. So here's catabolism schematic. So we've got proteins. They'll break down into amino acids, polysaccharides to monosaccharides, fats to fatty acids. Then they go through acetyl coenzyme A. Then they go through the citric acid cycle, and we go through the NAD, and then the ADP and ATP to oxidative phosphorylation, whatever you call it. So we're able to get more stuff for ADP, which helps us with energy. So this is stage 1 digestion. Okay, the first part where it just takes the proteins and breaks it down to amino acids, or the polysaccharides and breaks it down to monosaccharides. Stage 2 is when we're using our acetyl-CoA. So we need to know that in this stage we're producing acetyl-CoA. And then the last stage, stage 3, is the common catabolic pathway. So we have more things going on than just, and you do need to know those steps. stages. What? Are you okay? Are you done? Because we can stop and you can work on assignment if you overload it. I don't want to overload you and burn you out. Let's see what the next slide is, and we'll go from there.
Oh, let's just finish, because this is the last slide.
This is the last slide for this one?
One other one.
Okay, so let's finish this, and then we'll stop at the next break. Okay, so digestion of foods involves enzyme catalyzed reactions. So protein with hydrolysis gives us amino acids. Disaccharides and polysaccharides, when we hydrolyze, what does it mean to hydrolyze, by the way? Add water. Hydrolysis is adding water. So if I add water, then I'm going to get monosaccharides. Fats and oils, I go through hydrolysis. Fatty acids and glycerol, very good. Just because you did it because you were bored over the weekend, really?
Actually, it was more like I was at the library and I was bored, and I had read like a book and a half.
Okay, so here we've got this person. I like this fatty person. I would consider this one a fat child, right?
How did that one work?
Okay. Sort of reminds me of T-Rex, right? Okay, so you're eating carbohydrates. They come down into your esophagus, and you've got proteins and fat and little enzymes that are trying to break this stuff up in your stomach. And then that's lipase and the pepsin that are trying to break that stuff up. Then you get bile that's added from your from your gallbladder, thank you. And then the pancreatic duct that's taking things. And you've still got these enzymes that are trying to break these stuff down. You've also got bacteria and vitamins and fiber and waste that is now coming out. In your small intestines, a lot of that work gets done. The fatty acid and glycol and whatever's left over is known as feces. I have had my gallbladder taken out, yeah. But when you get your gallbladder taken out, you can't eat as many fatty things because your body can't break them down. You can't eat as many sweet things because your body can't break them down. No, it still has color. Sorry. No, it's still there. Okay, so when we're looking at coenzyme A, this is what you've got on there. You need to make sure you are able to recognize different parts of it. So the acetyl group, the first little part is an acetyl group. Then the pantothenic acid, that's a vitamin. And then the phosphorylic ADP, that last part. And the ADP, remember, that just means I have two of these phosphate groups. Okay, and that whole thing is called coenzyme A. So you do need to be able to recognize the different parts of it. All right? And I think we're on to the next part. So we'll stop right here, and we'll start at 22.7. Mark on your things for me. Sorry. Work on your assignment.